Okay, so lesson 4, properties of real numbers. So the last lesson we talked about what a real number was and how to classify the subsets of those. So now we're going to use properties of real numbers to talk about some of the operations we can do with real numbers and some of those kind of like tricks that we can use with real numbers. So an essential understanding here is that relationships are always true for real numbers. Those are called properties, okay? And we use those rules to rewrite and compare expressions, which we're going to do a lot of in the next few units. So this is an important thing to kind of understand how these real numbers operate. So two expressions are equivalent if they have the same value for all their variables. So these properties show expressions that are equivalent for all real numbers. All right, so any numbers we work with, these properties are going to hold true. So the first one is called the commutative property of addition and multiplication. So this property says that changing the order of the numbers being added does not change the sum. Changing the order of the factors doesn't change the product, so it doesn't change the result of the multiplication. So essentially, commutative property says if I have addition or multiplication, that the order doesn't matter. I can reorder 18 plus 54. It's the same as 54 plus 18. Same as 12 times a half. It's the same as a half times 12. So commutative property, if I move the numbers around, it doesn't change the value or the result of my addition or my multiplication. Keep saying subtraction. Addition and multiplication. Another property, the associative property, says changing the grouping of the numbers in addition doesn't change the sum. Changing the grouping of the factors in multiplication doesn't change the product. So what that means is if I have two numbers being added and those are grouped and added to another number, if I change which numbers are being grouped, that doesn't change the sum, okay? So A plus B being grouped or B plus C being grouped doesn't change the sum. Same with multiplication. If I move those grouping symbols to group different numbers or to group a different set of numbers being multiplied, it doesn't change the result. So associative property says if I move the grouping symbols around, it doesn't change the result of my addition or multiplication. And then a few more. Identity properties are pretty straightforward. If I add 0 to any real number, it's the original number, okay? So saying 5 plus 0 is 5. Adding 0 doesn't change the value of a number. That's the identity property for addition, okay? And that's illustrated right here. If I add 0 to a number, it stays that same number. The product of any real number and 1 is the original number. That's saying multiplying by 1 doesn't change the value of a number. So the identity properties, I'm just going to write ID here. The identity properties of addition and multiplication pretty much ask, what number can I add to keep my value the same? What number can I multiply to keep my value the same? Moving ahead, the 0 property of multiplication just says if I multiply any real number times 0, my result is 0. So any real number times 0 is 0. And then the multiplication property of -1. Multiplying a number by -1 changes its sign. Now, that's an important thing. It changes its sign. It doesn't just make it negative. So -1 times 9 is -9, but we've got to recognize that -1 times -9 is +9. So it changes the sign. That's an important distinction. So the first problem is basically just us identifying the property. So 42 times 0 is 0. I can look back to my properties. That's the 0 property of multiplication. Number times 0 is 0. So I'm just going to say, and we'll do a little bit of abbreviation, okay? 0 property of multiplication, okay? Next, this one's addition, so it's going to be some sort of addition property. When we look at this, I'm looking at maybe either associative or commutative. Now here, I have y plus 2.5 being grouped this way. Then I have 2.5 and 28 being grouped this way. So that's going to tell me that is that, and I'll abbreviate it, that's that associative property of addition, okay? Because we didn't change the order of the numbers. That would have been commutative if I would have changed the order of my numbers. Here, I just changed the grouping, which numbers are being grouped with which numbers, okay? So I just moved the grouping symbols around, right? And then this last one, 10x plus 0 is 10x. Well, we look back. It looks a lot like the addition property, or the identity property of addition, okay? So I would say identity property of addition. And it's important that I say addition, a distinct difference between addition and multiplication, okay? So I'm just going to get you guys a little bit of practice. Looking at these two problems, I'm just going to write one thing I kind of made a mistake on here. It has x, y, and z here. This, right here, this should be z, okay? That right there should be z and not x. So sorry about that, but pause it, take a minute to see if you can find the properties, and then I'll show you my solutions when you're ready. Okay, so to finish out this video, I just want to explain my handwriting too, but this first one, A, and there I got it, the property that's illustrated there, I would say that's the identity property of multiplication, because saying multiplying 4x by what keeps it 4x? It's 1, so that's the identity property, kept the value the same. Now in B, I'm really sorry for that typo. I'll try and fix that in future ones, but when I look at this, x and x stay in the same order, but z and y, do you see how z and y get swapped around? That order gets switched. If the order gets switched, that's how we know it's commutative property. If numbers are changing their order, they're getting switched around, okay? So that's the commutative property, okay? So the next step in your lesson is going to be to practice identifying these properties, just so that we know how to deal with them and how to recognize them, because I really want us to understand that without these properties, we can't do a lot of the stuff we do in Algebra 1. So these properties build that foundation for future concepts to be more concrete in your understanding and more solid in your understanding as we move forward. So you can move to the next step, get some practice identifying these. It's super important that we understand these properties to apply them later.